So a few quick ideas about the Pythagorean theorem. This is example 3. You look at my formula, I have L squared plus L squared equal height squared. Oftentimes students learn this as A squared plus B squared equals C squared. I don't like teaching that way simply because your triangles can be labeled any way you want. So in this example, I draw a right triangle. If I call the right angle A, that really messes up that A squared plus B squared equals C squared. Because if you recall from previous lessons, when you label this triangle, your hypotenuse would be known as little a. This leg down here would be little c, and this side over here would be little b, this other leg. And so that A squared plus B squared equals C squared, that's actually false in this regard because your legs are C and B and your hypotenuse is A. That's why I like to teach and learn the hypotenuse as the sum of the squares of a triangle shall be equal to the square of the hypotenuse. Now, if I have values here, maybe I call this 2 rad 7 and call this 3, and I want to find the value of C. Nothing changes when I use a radical. I just have to look at what I am given in this triangle. I have a leg and a hypotenuse. And so for this example, I would say C squared plus B squared, that's my two legs, are equal to A squared. And then I throw the values in. I don't know C, so that'll be my variable. B was 3, so 3 squared. And A was 2 square root 7 that we want to square. Now at this point, we haven't talked a whole lot about radicals. And so it's a process where we're going to be developing how to work with radicals. I'm going to use my calculator. Obviously to square 3 we should be able to do that in our head. If I want to square this strange number, this 2 rad 7, I can go 2 square root 7. I just put it right in my calculator. And we'll put parentheses around that. And then I'll square it. And that comes out to be 28. Now I will explain how that works. What you're doing is you're squaring each component here. So 2 squared is 4, and square root 7 times square root 7 is just 7. So it becomes 4 times 7, which is 28. We'll talk more about that here in the very near future. When we look at the equation that I'm working with now, I have C squared plus 9 is equal to 28. I can move my 9 over, so C squared is equal to 28 minus 9, which would be 19. And then the last step is always to take the root of both sides. So I root this, I root this. C will equal rad 19. And then I can use my calculator again to do a decimal approximation. So I'll do the square root of 19. And usually from problem to problem, you have to pay attention to how far they tell you to round. So maybe on this problem they're telling me go to the nearest hundredths. When I look at this value where it says 4.35889, I have to look at the third decimal place to round to the hundredth. And so when we round, we want to say that C is approximately equal to 4.36. Always round appropriately. Always round appropriately. So I got my 4.36. I can go back to my calculator. Now this one, like the previous examples, I may not know if that makes sense or not. So I may have to actually use the calculator a few times. I want to know what approximately is 2 rad 17, or 2 rad 7, pardon me. So I go 2 square root 7. That's 5.29. 5.29. When I look at this being 5.29, here this leg being 3 and this leg being 4.36, it makes sense because the hypotenuse should be the longest side, the longest length in the triangle. So now you have 3 examples for the Pythagorean theorem.